Hello and welcome everyone to another new video. Today we are discussing lead code biweekly 102. First problem, second problem, and fourth problem. I'm not able to make with third problem, so we are going with three. We will understand it deeply and have a look over solution. And you will be getting what intuition nearly need to be there if you need to solve much more problems in a live contest. So let's go forward. Okay, so find the width of the column of a grid. Okay, this type of question you need a proper observation. You need to read the question properly and come up with an brute force intuition that will work because it is an easy question. Constraint will be not that much big. So let's see the question. You are given an zero index m into an integer matrix. The width of the column is the maximum length of its integer. Okay, width of the column is the main word in this question. Okay, for example, here given minus 10, 3 and 12 in a grid. Minus 10 is a separate row, 3 is a separate row, and 12 is a separate row, and it has only one column. Okay, get it that? Get it that? Okay. So then the maximum width of only column is minus 10, that is 3. Okay. So you need to convert this integer into string and measure its length and just store the maximum one in your answer. What you can say that answer vector or answer array. So that is the minimal observation that you made, and constraint are 100 improvements m into n will be 10 to the power 4. It will be nearly acceptable. Okay, no problem. Typecasting will not needed. It will work in a integer. Okay, you have defined your rows and columns and the answer vector as res, and you will be going to traverse over all the rows and over the all the columns, and every column has its maximum. Here is that particular length of that particular integer, and you will going to store max for that particular column. Okay, so that is how you do it. It is a pretty simple question. Let's submit it, and it is accepted. Okay, let's move forward with our second question. Find the score of all prefix of the array. Okay, this is another good question of observation. What you can say that you define a conversation array, that is a conver of array as follows. Okay, conversation of array will be ARR of I. The current element of convert, that is conver of I, will be equal to ARR of I plus maximum of ARR of 0 to I. Okay, so where if you are at jth index, you will be sum with ARR of j. Sorry, what you can say that if you are at ARR of I, the sum of ARR of I plus ARR of j, that is the maximum element throughout the stream that you cover previously. Okay, this is a perfect example of prefix sum that will work here. Okay, you will also define a score of any array ARR as sum of the value of conversation of array ARRF. Okay, this is a hint for the what you can say that have a solution overlook. Okay, you're given zero index array. Okay, return answer array, length of an answer of I is the maximum score of the prefix 0 to I. Okay, this is what really means. Okay, we are going to start with this example 2, 3, 7, 5, and 10. Okay, so here we comes, and our maximum element will be till now will be integer minimum, and here it becomes 2. 2 plus current element is 2, so 4. 4 is the current our prefix sum. Okay, just stored it, current prefix sum. Okay, you are come with 3. Now the maximum element will be 3. 3 plus 3 matlab max element plus current element 6, and our prefix sum is 4, so current will be 10. Okay, uh, you have come with 7 now. 7 maximum plus current element 14, and our previous sum is 10. Last element access last element, just add it, prefix plus max. Okay, get it point. What is here what is prefix? 24. Okay, 24, fine. Here maximum element also 7. 7 plus 5, AR of I plus maxi, AR of I plus maxi, remember that thing. 12. 12 plus last sum 24, that is 36. So what it really means here, maintain a sum variable simply which will be going to your maxi, what you can say that last prefix sum or last element of the array, simply that our resultant array, and add current element plus max element plus last element of the array. That is what the real question really means. Okay, you can deeply understand by pausing this video here and check for this. Okay, check for this test case simply. Okay, sum variable, maxi variable, and previous element of the array. Okay, so here you go. Here's our maxi element, that is integer minimum, long sum. Typecasting may be occur or may not. I think may not, and but it is important to be there any edge cases. Okay, so here what is the return type is long, so you can maintain a long. Okay, no problem. Here you're going to compare with every element and just adding with the maxi plus current element, and this sum factor is the prefix sum. After every operation you will be going to add it. Okay, prefix sum, last sum, just add. And here pushback, what is current maxi plus last sum. Okay, so that is what it really means. Simply return it and go for it. Okay, so this is a pretty much basic questions that you will be going to do if you have a good observation skills, and you can do it, bro. Just move forward with the fourth one, the my favorite one, registrar shortlist path algorithm, special and proper question of lead code biweekly 102. Okay, so here is what the question really means. Submission are really good, huh? 3000 submission on the hard question is not really seems in any contest. Okay, let's go forward with it. Design graph with shortest path calculator. Okay, there is an directed graph that consists of n nodes from 0 to n minus 1. Okay, as a proper graph explanation, the edges of the graph are initially represented by the given array edges. Okay, so what proper understanding of graph, shortest path from to, and the weight of the graph, weighted graph, that things are really good. Okay, so you need to practice much more. This will be enjoying for you. This is a pretty much easy question of the graph. Okay, minimum that there is an edge from I to I. Okay, with cost edge of I. Okay, this is a easy thing that you can understand pretty muchly. Implement the graph class will be consisting of n what 0 to n minus 1 edges. So n adjacency list of n element, getting some hint. If you got, just go and solve it, come back if you not. Okay, so here also edges, 2D vector of edges is given, that previously given some edges from 2 to and edge cost with some edge 2D vector. Okay, and add edge class, which will going to add edge from to an edge cost. Simply that thing. Adjacency list, preparation of adjacency list of pairs. I am giving you hint, adjacency list of pairs from what is edge cost and edge from adjacency list of it of 0, what you can say, the edge of I of 0, pushback edge of I of 1 comma edge of I of 2, edge pair of adjacency list, that is 2 and cost. Okay, so that is what it really means. You just need to return the shortest minimum cost between node 1 and node 2. If no path exists, return -1. The cost of the path is the sum of the cost of all the edges in the path. Okay, so what it really means, the proper example of Dijkstra's shortest path algorithm, what you can say that using min heap, or you can do it in what you can say that normal queue also. That is not important. You will be going to use always priority queue. Priority queue will be minimize your time complexity into E log V. And that is a proper thing that you can get if you have a good understanding of graph. Okay, so let's see here. You are given a graph class with 4 edges, and these are there from 2 and edge weights. We are just going to make a adjacency list from, okay, adjacency list of 0, pushback 2 comma 5, adjacency list of pairs 2, and the weight particular that. Okay, this will be done in our first step, and then we're going to, for the Dijkstar shortest path algorithm and short path functions, short path method, you just implement that and return, if there is a path exist, what you can say that you make a resultant vector for storing the path from current, what you can say that shortest path given two inputs. Okay, source and destination. From source to every node we were going to calculate the shortest path, and if there is an positive distance or a distance between okay, so here is another thing, that there is a no repeated edge, no self loop in a graph at a point, and we can consider that there is a no negative cycle, because edge cost is greater than or equal to 1 and less than or equal to 20 to the power 6. It is the main concept of this question. There is no negative cycle. If negative cycle, you need to use the Bellman-Ford algorithm for finding the shortest path. Okay, so this is the thing that minimum observation that you need to make from the constraint also. So shortest path, what really means, simply from 0 to from source to destination using priority queue or queue discharge shortest path. Simply you can do that. And add edge, simply method that has consist of 3 from 2 and edge cost. Okay, so let's see directly code. It will be easy for you to understand by means of code. Okay, so what you will do here, you will do simply declare adjacency list of what you can say that maximum load will be 100. So 101, you can declare the adjacency list of 101 and simply push all the directed edges from 0 to 1 with edge cost of 2. Okay, then again you will be do similar things in add edge functions method, or what you can say that here you initialize a resultant vector of 101 with integer max. Maximum cost will be integer max initially for every node, and we will be going to declare for starting node as 0. Okay, starting node the cost will be 0, and this is a priority queue, basically mean heap. And we are pushing our first will be our distance and then our node. Okay, so shortest distance, so first distance then node. Okay, so while this is a proper example of discharge shortest path algorithm, you can go forward with the code. Distance, we will take out the distance, we will be going to take out the node, we will be going to all possibilities of the node, and just, yeah, if it is less than, okay, if we will reach now here with the minimum cost from this node from the distance plus current cost, then we will going to just initialize that cost to that particular node and just push in the queue. And at the last, if it is equivalent to integer max, it means there is no path, return -1. If it is their path, simply return that minimum cost of the path. So it is a pretty much simple example. You can move forward with an intuition and you can do it. Just practice more. Hope you are all doing well, and please make sure to like, share and subscribe to the video and channel, and we will be meet you in next lecture very soon with a discussion of weekly, another weekly or bi-weekly contest. So go forward with it. Okay, thank you.